Today we're going to be looking at frequency modulation synthesis. We're going to be using the Moog Werkstatt to take a look at what it can do. We're going to take a look at some of the components of this wonderful little synth, and we're going to finish with a demonstration of how powerful frequency modulation synthesis can be. Simply put, FM synthesis is when you take one frequency and use it to modulate a second frequency. Let's dive into some of the assembly of the Moog Werkstatt. It is a synthesizer that you assemble on your own. First, let's take the back casing, flip it over to the back side, and install the 4 rubber feet, which just press right into the holes. Next, we're going to take the circuit board, put the plastic O-ring over the 1/4-inch cable thread, and place it onto the frame. Next, we just need to screw in the 5 small sheet metal screws to secure it into the frame. And then finish by screwing on the 1/4-inch hex nut onto the end. This time, plug in the synthesizer and make sure that the LFO LED is illuminated to make sure that the synth is working. After you do that, install the 13 buttons simply by just pressing them in. Next, you're going to want to place the casing of the synth over, and then tighten the 2 screws on the right-hand side. Then you just need to snap the CV expander into place, and then tighten it down with its 2 separate included screws. Finally, you just need to flip the synth over and attach the sticker that has the synth serial number on it. After that, you've got a completed Moog Werkstatt. Now let's get into some of the components of the Moog Werkstatt. First, in the top left, we have the VCO, or voltage controlled oscillator. It has a frequency knob to control the frequency of the oscillator, as well as a waveform selection switch, which lets you choose between pulse and sawtooth waveforms. It also has a PWM, or pulse width modulation knob, which affects the modulation amount of the pulse wave. Below that section is the VCO mod. It has a source selection switch, which lets you choose to get its source from the LFO or the envelope of the synth. It has a modulation amount knob as well as a destination switch, which lets you choose between the PWM knob as well as the frequency of the oscillator. To the right of the VCO is the VCF, or voltage controlled filter. It has 2 simple controls, a knob for cutoff and resonance. Below that is the VCF mod. Just like the VCO mod, it has a source selection switch and a mount knob. However, unlike the VCO mod, it has a polarity switch. Right next to the VCF is the VCA, or voltage controlled amplifier. It has 1 simple switch to let you choose whether it's going to let the oscillator run continuously, or if the oscillator is going to follow the amplitude of the envelope. The envelope is located in the lower right of the synth. It has a sustain switch to let you choose whether sustain will be on or off, a knob to determine the attack time and decay time. Next to the envelope is the LFO. It has an LED light to show you the speed of the LFO rate. It has a knob to control the speed of the LFO rate, and it also has a selection switch to let you choose between square and triangle waveforms. Below all that is the keyboard. It has a simple 1 octave of buttons ranging from C to C. as well as a glide knob to determine the time it takes to change from one frequency to the next. Next, let's go to the CV expander across the right-hand side of the synth. CV is short for control voltage. Just like an audio waveform, CV waveforms have relative high and low points, although they operate at much lower frequencies. CV signal, however, is not meant to be listened to, but rather used to control the parameters of different sections of the synth. One of the easiest ways to think about CV is to imagine CV as invisible hands controlling the knobs of the synth. For example, if I plug the LFO out into the gate in, the LFO will control how open the gate is, affecting the volume of the signal.